Now let's move on to the next condition. That is when our R is greater than 2. So let's comment that one out also and say check if Ly over Lx is greater than 2. Yes, so we will write if our function R is greater than 2, then we'll do another print statement. So print into brackets a string character again. So in this instance, we'll have a one-way condition on the longer spans of the panel. So we have a one-way distribution towards the side, towards the Ly. So this is our grid line A, this is our grid line B, grid line 1 and 2. Right. So let's comment that one out and write. So check if Ly over Lx is greater than 2. And then we'll continue the code as if our function that we've defined earlier on is greater than 2, then we are going to do another print statement to return the tributary areas on grid lines A and B. So we'll do print the brackets, then we put in a string character. So tributary area on in A and B equals, so it's going to be a one-way load distribution. One way yes, it's equal to one way. And then we'll move on to the final condition. That's when the ratio of our Ly to Lx is equal to 1. So we'll say, let's comment it out first. So check if Ly over Lx equals 1. So in that case, our Ly is equal to Lx. Ly is equal to Lx. And the ratio of our Ly to Lx equals 1. Okay. So we'll write the code as if R is equal to equal to 1 and Ly equals to Lx. Then we'll do a print statement again. So print the bracket. We are going to use a string character. So print tributary area on beam A, B, 1 and 2 equals triangular. Right. So let's try and implement this condition also. Let us run the code now and try and input values that will give us this condition. So we come here. So let's use say 6,000 mm, and then the long span is also 6,000 mm. That will give us a ratio of 1. Okay, so our R has been calculated as 1, but the tributary area is not what we are expecting. So we would have to go back and try and adjust this condition, because we are saying that if R is less than 2, it should always do this. And here again, our R is equal to 1. So that is why we are getting these results here. So we'd have to come to this first condition here and try and adjust this line of code. So what we can do is we can, put this R, we can do a range and say if our R is between 1 and 2. So we'll say if our R is between 1 and 2, right, then this condition will hold. And then if our R is equal to 1, then we would expect a triangular load distribution, on all the panels. So at this point, let us run the code and check all the three conditions. So the first condition will be when we have our R less than 2. The second is when our R is greater than 2. And then the final condition is when our R is 1. So let us debug and enter Lx. So let's use the values that we've been using previously. So our Lx is 4,500. Our Ly is 6,700. Okay, so our R is 1.488. Tributary area on beam A and B is trapezoidal, and that on beam 1 and 2 is triangular. Okay, so let us check this condition also if R is greater than 2. So let's run the code again and check. So in order to achieve this condition, we need to alter the values a little. So we'll do 2000 mm as the short span and 7000 mm as the long span. So in this case, our R is 3.5 and tributary area on beam A and B is 1 way. Now let's check the last condition. So we'll run the code again and let's use 6,700 mm and 6,700 mm. Wait, so now the code has worked after altering this line of code here. So it is returning the triangular load distribution on all the four corners. Now the next thing we are going to do is to allow the user input the dimensions of beams within the panel. So let's comment that one out and say input input beam dimension. Okay. So coming back to our panel, let's assume beam on grid line A and B and 1 are 200 by 600 mm, and that on beam on grid line 2 is 200 by 450. So we are going to input these values into the program or the code. So the first one we are going to do is, so I'll comment that out also and say beam dimensions of beam A. And our first line of code will be, so let's represent the depth of beam A as h1. So we'll say h1 equals, and we'll do a float again as we did previously. Do float into brackets, and the user is going to input the dimensions of the beam. So we'll do input, another bracket, and then we'll put a string character. So yes, and we'll write enter depth of beam A. So we've been able to define the depth of beam A. We can copy this and change the code to suit that of the width. So just paste it down and change. So represent the width by V1, and then we'll change this to width of beam A. So we've been able to define the depth and then the width of beam A. We can copy this and bring it down and change this to beam dimensions of beam B. We'll change this to H2 and this to B2 and this to B. Okay. And again, we'll copy this and change it for beam on grid line 1. So this will be beam 1, and then let's change this to H3, B3, and this will be beam 1, beam 1. And then finally we'll copy the definitions of H3 of beam 3 and change it to suit beam on grid line 2. So do this H4, B4. So this is beam 2, and this will change this to 2 and 2. So what we've done is, going back to our panel, we've written a code to allow the user enter the beam dimensions on all the four beams